Hello students, welcome back. Now let's go to section 4, Normal Probability Distribution 2. Now in this notebook, I have two sections with very similar names, sections 2 and 4. How do they differ? In section 2, we introduced the basic ideas of normal random variables and saw some properties of the normal density function, went through a motivating example, and finally, we discussed a transition toward the standard normal. And then, after we study standard normal in section 3, in section 4, we have a transition from the standard normal, and then using that, we're going to discuss a couple of exercise problem sets that go hand in hand, parallel with the previous exercise set we discussed in section 3. That's the plan. Now, how does the transition work? Well, here is the conversion formula, which I often say the formula number 1 for this entire course in terms of the level of importance. Let x be a normal random variable with the expected value mu and the standard deviation sigma. Then this algebraic manipulation, z equals x minus mu over sigma, will give us the standard normal random variable. The normal random variable with mean 0 and standard deviation 1. Now, how do we use it? One way to understand it is to go through an example problem, and let's go ahead and do exactly that. Suppose that the mean and the standard deviation of a normal random variable x are given as these, 16.75 and 0.451 respectively. And then let's estimate this probability where x is less than or equal to 16.01. Alright, how do we do that? One way to handle it is to use this conversion letter by letter. How do we do that? Let's start from here. X is less than 16.01. Alright, this and that are the same. And then let's algebraically manipulate. Sorry about that, a typo. So let's subtract the same thing both from left hand side and right hand side. So I didn't change anything. This one here and this inequality there are the same. They're identical, so no change. Now here, divide both sides by the same positive real number, and I'm going to divide it by this. So what happened? I got x minus mu over sigma, and here I got, well, x minus mu of sigma, where x value is 16.01. Did I change anything? No, not really, because I subtracted mu from both sides of the inequality and divided by sigma, a positive number, from both sides of the inequality, so nothing changed. So this inequality and that inequality are the same, so of course the same probability. No change here. But then again, this manipulation helps us to use this conversion formula, so this part is z, and thus z is less than 16.01 minus 16.75, the mean, and divided by 0.451. Alright, what is this quantity? All you have to do is to punch into calculator and do your computation. If you do it right, you will see that this is negative 1.64, approximately speaking. Want to check? Yeah, negative 1.64. And as for negative 1.64, Well, we got standard normal, so all you have to do is to check the random variable. Check the standard normal table. And where is it? Here, go to z column, -1.6. And then in this row, 4 column, 0.0505, and that is the answer. And that's the solution. This is not the best solution, but here it is. Were you able to follow all those equivalences based upon this conversion? If you can follow it and if you like it, that's great. Maybe you are headed toward mathematics major. Maybe you want to take calculus-based statistics course in 3000 level pretty soon. But most of the students do not like this kind of symbolic manipulation. It's not an easy thing to do. I did it only once here, and I'm not going to come back and redo this ever again because it's perfectly theoretically sound, but it's a bit too difficult to understand for most of the students anyway. I needed it here because I wanted a theoretical foundation. Now that's set, let's discuss a bit more practical method. Let's name it as solution 2. And instead, let's discuss a bit more practical method. Instead of going through all those symbolic manipulations, let's discuss a method that is based upon a little bit more graphical approach. First, draw a normal picture, label it accordingly, and then shade it. After that, conduct z computation. What do you mean by the z computation? Well, here's a formula. Z is x minus mu over sigma. That's what I mean. Z is equal to x minus mu over sigma. As a matter of fact, there's even better way. Z equals to end minus center over SD. What exactly does it mean? We're going to come back and discuss after the picture. And step 3, go to the standard normal table and get the probabilities. If you just need one probability, great, that one. If you need multiple, then get multiple, and you may have to do some computation with those. That's the procedure. Ready? Okay, here we go. Let me turn on the graphics mode. All right, step 1, draw a normal picture. Okay, I'm drawing a normal picture. It doesn't have to be perfect. Anything reasonable will do. Outline, and then the center, and that is 16.75. That's the mean. Is that clear to everybody? Yes, 16.75. And then what do I want? I want 16.01 or less. And where is it? 16.01 should be over here. It's less than 16.75. So it's got to be here. And then I have to shade. It's less than 16.01 that I'm looking for. So shading is to the left. It's the left-hand side shading that I have to do. Okay, the picture is done. Labeling done and shading all is done. Now let's go to the z computation. Z is x minus mu over sigma, as the conversion formula says, or equivalently, end minus center over SD. So x minus mu over sigma, or if you look at the picture, end minus center over SD. So Z computation is end 16.01 minus center 16.75. This looks almost like 10, that too. Divided by 0.451. And if you do this computation, you're going to get negative 1.64, approximately speaking. So once you get your z-score, then you can always go to the standard normal table, find out the z column, get up to first decimal digit, 1.6, and then go to the second column and get your probability. And that is the left-hand side shading. In this case, that's all you need. That's the answer. We wanted the left-hand side shading. So the left-hand side shading that you got from the Z table is the answer. You don't have to do anything else. Well, it's very, very crude with all these drawings. I mean, I didn't write anything. I drew everything, so it was very difficult. Let's get out of this drawing mode and let me show you a lot better solution. Let's open it here. And here's a much better picture. Centered at 16.75, the mean, and 16.1, that's the end. And we need left-hand side shading because we want x is less than 16.01. And then this picture is the normalized version, the standardized version, excuse me. And in hand-drawn picture, this one is redundant. Only the first picture is necessary. Once you calculate the z-score, x minus mu over sigma, we get the z-score, and that is the standardized value. So you can use the standard normal table, and in the end, you get the CDF value, the left-hand side shading, 0.0505 in this case. That's how you do it. This is more practical method. And by the way, over here, x minus mu over sigma, that's the same as end minus center over SD in terms of this picture. Now, this expression, in my opinion, is better than x minus mu over sigma. Why? Because there are many versions of this. X minus mu over sigma, mu minus x over sigma, x minus x bar over sigma, mu minus x bar over sigma, and x bar minus mu over sigma over square root of n. There are many more. Too confusing. So there's no way you can track everything down in this form. But once you draw the picture, yes, you need a picture because all these are referring to the picture. And then you get end minus center over SD, then bingo. You can handle any kind of problem. All normal or semi-normal or normal-like problems. You can do all those with this. And that's why this one here, this version, that is the formula number 1. This one, if you count in all the other versions that converge to this end minus center over SD, yes, that is formula number 1. But in this form, it's difficult to handle. So draw the picture and do this end minus center over SD. Then you can do this kind of problem easily. Let's stop here, and then we're going to discuss problem B in a separate video. Stay tuned.